Okay. Good. Do you see well? It's okay?
Yes.
You want it a bit bigger?
Yes.
For some reason, it's impossible to set it. Wait, I'm trying to set up my camera because I don't have a good webcam, so I'm using the webcam of my iPhone as a webcam, but it's a bit messy. Okay. Good. Voila. Okay, last time we were talking about refraction, and we still have an exercise to do about refraction. Okay? You remember that one?
Yes.
Okay. So I'm going to, I'm going to do the calculations on a separate sheet. Okay, so we have this aquarium. We have a light ray which arrives with an angle of 40 degrees with respect to the interface. And we need to find the path of the light ray inside the water. We will see that there will be more than one refraction. Okay, so at this point here, we have the first refraction. I will call it refraction 1, and I will write the equations here. Okay? So we need to identify first of all the angle of incidence. How much is the angle of incidence here? Hello?
It's 40.
No, it's not 40. Okay, this is a trap because
It's 50.
the angle of incidence is always defined with respect to the normal. Okay, so the angle of incidence here is 50 degrees. Okay, you have to be careful about that. The angle of incidence is 50 degrees. Now the index of refraction of the first medium of air is 1, of course, since it's air, and inside the water we have N2, which is the index of water, which is 1333. Okay? So for the first refraction I can write Snell's law. Okay, and what I want to calculate is R. We know that N1 is 1. We know that the angle is 50. We know that N2 is 1333. And so this means that R is the inverse sinus of what? Of N1 sin 50 over N2. Over N of N1 sine 50 over N2. Okay? And this, could somebody compute this for me? Because the problem is that my iPhone, now I use it as a camera, and I realize that I don't have in my house a decent calculator. I have one, but it's a financial one. It doesn't have sine and all that. Okay, could somebody compute that for me? So it's the A sine of sine 50 over 1333. How much is that?
I have 35.1.
35, let's say 35. Okay, 35 will do. Do you think it's correct? We are going closer to the normal. Is this correct?
Yes.
This is what you expect? Yes, because we go from a fast medium to a slow one. Okay, so here we can now draw the subsequent path of the light ray. Okay, we have the normal, which I should trace a bit better. This is the normal. Okay, and now if I want to measure an angle of 35 with respect to the normal, I need to go here, take 35 degrees, which is here, and so this allows me to draw a line for my light ray. Okay? It's fine? Good. Okay. Of course, now we are going to have a second refraction here. Okay? Because here we are again touching the interface between water and air. Okay? And the second refraction, I will compute it on this page here. I hope it works. Okay, the refraction, the second refraction, which I call R2. What do we have? Again, we write Snell's law, N1 sine I is equal to N2 sine R. And now we have to identify what are N1, N2, I, and R. N1 is what in this case?
Water.
It's water, okay? It's 1, 3, 3, 3. The angle of incidence is how much? And here you have to be a bit careful, because the angle of incidence now is defined as the angle with respect to the normal, but now the normal is here. So we need to compute this angle here, okay? And if we want to compute this angle, how can we do it? Well, we have this triangle here. We know this angle, we computed it before. This angle was 35. This angle here is 90. So this angle here is going to be 90 minus 35, which is 55. Okay? Okay? Or not? So the angle I is now 55 degrees. Then what is the index N2 for this refraction here? Sorry? It's 1, okay? Because it goes into air again. So N2 is 1, and the angle of refraction, this is what we are trying to compute. So R is the A sine of what? Of 1.333 times the sine of 55 over 1. Could somebody compute that, please? And here you may get a surprise.
It says domain error.
Yes, exactly. This gives you domain error. Why does it give you domain error? Why do you think?
Because it's bigger than 1.
Exactly. Okay, the sinus function takes maximum value 1. It oscillates between -1 and 1, and so you cannot compute the sinus, the inverse sinus, sorry, of something which is bigger than 1, and this is bigger than 1. Okay, so it doesn't work. This means if the computation doesn't work, this means that you have total reflection. Okay, and indeed we arrived with an angle of incidence of 55, which is high, and so indeed we have, you know, the limiting angle was about 42 degrees, so 55 degrees is too big, and we cannot have refraction. We have total reflection. And so we need to apply the rules of reflection. And what are the rules of reflection? What is the rule of reflection?
The angle of incidence is equal to the angle of
exactly.
reflection.
So here we had an angle of incidence of 55. So we are going to have a reflection with the same angle of 55 degrees, which is here. So I can now draw a line which is like this. Okay? And now what do we do? What's happening here? Here we have another refraction which I shall call R3. Okay? And we are going to compute R3. Where is the normal for this refraction? The normal is here. And where is the angle of incidence? It's here, right? So what is this angle? What do you think? You know that we have an angle of 55 here, okay? And so the angle which is here is again 55, okay? Because it's the opposite angle between it's the angle between one line and two lines which are parallel. So you find the same angle here. If you have an angle of 55, you are going to have the same phenomenon as down here, which means total internal reflection, right? So we don't even need to do the calculations. R3 is just going to be a total internal reflection, and so we are going to leave from there with an angle of 55 again, okay, and it will give us, sorry, it's getting a bit small now, it will give us something like that, okay? And then we arrive here and we have our last refraction here to be computed. The normal is here. What is the angle of incidence for this refraction? R4. R4. So I'm now, oh god, it's a bit small, I'm sorry. Okay, we can make it. So R4, I need to write again N1 sine I is equal to N2 sine R. Okay, N1 is what? Well, we are in water, so N1 is 1333. N2 is air, it's 1. The angle of incidence is how much? Now we need to compute this angle. Okay? So we can compute this angle within this small triangle here. Let's draw this small triangle and copy the angles. This angle here is 90 degrees. Then the angle here is the angle of refraction for the previous refraction. This is 55. And so this angle here is going to be 90 minus 55. It's going to be 35. Okay? Right? Hello?
Yes.
Yeah. Okay. So I is 35. Do you expect to have a refraction or a reflection with an incidence angle of 35?
Refraction.
Refraction, because it's smaller than the limiting angle, which is about 42, if I remember well. So this means that R is the arc sinus of N1, which is 1333, times the sine of 35 over 1. And could somebody be nice enough to compute that? But I know the result. Do you know the result? It's going to be 50. Because previously we computed that refraction, it was going in that direction, we had 50, and after the refraction we had 35. And now we are going to do the opposite. We are going to pass from water into air with an incidence angle of 35. So the angle of refraction is going to be 50. Okay, we are going to go further away from the normal, and so here it's 50. It's going to be something like this. Okay, and here, sorry, it's 50. Yeah, 50. and here we are going to have our angle of 50 degrees. Okay? Sorry, the drawing is a bit small. For other classes I redid it on a separate page. Okay? But basically you have 4 different refractions to compute, and every time you have to be careful to identify the index of the substance from which you are leaving and the index of the substance in which you are going. Okay? No, I cannot put everything.
I just have a question.
Yeah? Tell me.
On the little drawing, how do we know it's 50 degrees? The first angle.
Because what is given in the exercise is this angle. And so what you have to compute is the complement of this angle to 90 degrees, okay? Because the angle between the normal and the interface is 90 degrees. So 90 minus 40 is 50.
Okay, yeah, thank you.
Simply. Hmm?
And how did we find the 35 for the last one? The angle of the...
Well, you have to look at this triangle here. Okay, this triangle here, if I do it a bit bigger, what are the angles? This is 90 degrees, of course. This angle here is the angle of reflection for this total reflection here. We had incidence 55, so the angle here is the same, it's 55. Okay, and this angle here is going to be 90 minus 55, and this is 35. Okay?
Yep.
I didn't understand.
Can you just like put the paper with up like this? I can take a picture.
This one or the other, or the other page?
The other one too.
Hmm? The other one?
The other one. Thank you.
You're welcome. Anyhow, I am now recording this class. I will put it on my YouTube channel. If you want to watch it again, you are welcome to do it at any time. I'm putting all my courses online anyhow. Okay? For those who have not been able to attend or for other reasons. Good. So now we are going to start lenses. Okay? Lenses, lentilles. Okay? We are going to start lenses. And lenses work based on the principle of refraction. Let me explain you that. Let's imagine we have a lens which has this shape. Okay? This is what we call a convergent lens. And let's imagine we have a light ray that arrives, let's see here. Okay? And let's try to approximately draw the refractions that happen. I don't want to calculate everything because it's going to take hours, plus we don't have really nice angles here that we can measure. This refraction is going to do what? It's going to go closer to the normal or away from the normal? Hello?
How can we know?
We are going from a fast medium to a slow medium. Okay, outside the lens we are in air, and inside the lens we are in glass. Okay, so the index of the glass is 1.5, so the velocity of light inside the glass is lower, and so there will be a refraction. Okay, and when you go from a fast medium to a slow one, generally, I mean, not generally, in all cases, you go closer to the normal. So now let me draw the normal. The normal is perpendicular to the surface, okay? So I can draw my normal like this. right? And now the angle of incidence is here, and if I go closer to the normal, it means that after the refraction, the angle between the light ray and the normal here will be smaller than the angle of incidence. Okay? Yes? Good. Now we have where the hell is my blue gone? Oh, la, la. Well, whatever, I lost the blue. No. Ah, no, it's here. Now we have a second refraction here. Let's draw the normal. The normal is perpendicular to the surface, so I take a tangent to the surface and I draw the normal. Okay? And now, in that case, going from a slow medium to a fast medium, do I go closer to the normal or away from the normal?
Away.
Away, exactly. So here we have a certain angle of incidence, which I color in blue so you see it well. Okay? And after the refraction, the angle, oh God. Ah. I don't know why it's disconnecting all the time. If I connect it via Wi-Fi, it's slow. If I connect it via USB, oh God, my phone went out of battery. Why the hell? Oh. Listen, let's do it differently. Parce que là, j'en ai marre. I mean, I've spent days trying to fix my equipment and my different things, and it's a mess. I had to buy a lot of equipment to make my connection decent,